relative velocity. We, standing on the ground, observe something. Then we notice the velocity of that thing relative to ground. This should be written as velocity of object that we are noticing, velocity of the body with respect to ground. Say we are seeing the velocity of bus standing on the ground. This will be velocity of bus minus velocity of ground. But since you are standing, so that is always there with everyone, the person who is observing, the person who is noting. That's why it is not the convention. We do not mention the velocity with respect to ground. We would simply say velocity of bus. Velocity of bus is 60 km per hour. It means it is with respect to ground, and this is not the convention to mention with respect to ground. We normally speak velocity of train, velocity of bus. So when you observe the velocity of something, that is the absolute velocity while you are standing. The observer is at rest, observer is not moving, he will always notice the absolute velocity. Concept of relative velocity is applicable only when the observer is moving. Something is moving, person who is observing, he is also moving. For example, one squirrel, it's climbing the tree, and one mouse is going towards the tree. Both are in motion. Mouse is observing the motion of squirrel and vice versa. Both will observe the relative velocity of each other. Why? Because both are in motion. So relative velocity will be applicable in that case only. Then suppose here it's given velocity of p, velocity of q having angle theta. In two cases, you'll have to think in different way. You say velocity of p with respect to q. This is the way. And in that case, what you will do? You subtract velocity of q from velocity of p. While saying velocity of p relative to q, who is observer? Observer is q. With respect to q, it is being discussed, means observer is q only. And we have to remember the velocity of observer is always subtracted. You say velocity of q relative to p, then what you'll do? Here you will subtract vp because you have taken the velocity of q with respect to p. The two cases have been shown here. If you want this thing vpq, you will subtract this vq, means vq will be reversed and added. This is vq, this will be minus vq. It has been reversed and then added. Similarly, I'll show you here. You want vqp. Then what will you do? vq first. This is vq as it is, and minus vp. Minus vp means vq minus vp. This becomes vqp. This is velocity of q with respect to p, whereas this was shown velocity of p with respect to q. More or less, you will find both are equal and opposite. Means vp minus vq or vq minus vp, both will be equal in value. This is the formula that we have used here, is simple formula for the resultant or difference of two vectors. Vp and vq, their difference, the formula would be given this way. And if the relative velocity makes angle alpha with p, you'll have the formula vq sin theta upon vp plus vq cos theta. For finding relative velocity, if both are in the same direction, you'll have to take the difference for finding relative, and if both are in opposite direction, you'll have to take the sum of both the velocity.